In section 4.1, the objective is to be able to classify triangles by their sides and angles, find interior and exterior angle measures in triangles, and use properties of isosceles and equilateral triangles. A triangle is a polygon formed by segments joining three non-collinear points. Remember, non-collinear means not in one line. So if I make 3 points that are not in one line and then I join them with segments, I'm forming a triangle. Three angles, triangle. To classify a triangle, classify meaning to group it, we can use either angle names or side names. Acute triangle has 3 acute angles. If we draw an acute triangle, we need to make sure that we are drawing it such that all 3 angles look acute. An obtuse triangle has 1 obtuse angle. So when I draw an obtuse triangle, I usually start by drawing an obtuse angle, see how this angle looks greater than 90 degrees, and then connecting to make the third side. A right triangle has 1 right angle. So similarly to the obtuse triangle, I start by drawing a right angle and then I connect to make the third side. Equiangular triangle has, look at what this part of the word is, equi is like equal. Angular, angles, has 3 congruent angles. So when I draw that, I try to make all 3 angles look like they're the same measure, but we need to mark that they're the same measure with angle congruent marks. So this is just a review of how to classify triangles by their angles. Here's a review of how to classify them by their sides. Equilateral. Lateral refers to the sides. Equi again for equal. So equilateral has 3 congruent sides. And we can draw that, again, the sides all trying to look congruent, and put congruent marks through the sides. An isosceles triangle has at least 2 congruent sides. So when I draw it, I try to make it look like 2 sides are congruent, and I put congruent slashes through 2 of those sides. Now notice the words at least, because it could have 3 congruent sides, which means it could be equilateral. An isosceles triangle can be equilateral. So I can have it like this because it has at least 2 congruent sides. Scalene has no congruent sides. So if I draw a scalene triangle, either I mark all the sides with different marks or with different measurements. Let's review how to name parts of a triangle so that we're all speaking the same language. These points where the segments are come together are called the vertices. There are 3 vertices. That's how we say it plural. One of the points is a vertex, the vertex. The segment that joins the vertices are called the sides. Then we have inside, one of the angles is an interior angle. And if I extend the side like that, I can draw outside of the triangle the exterior angle. That's one of the exterior angles in the picture. Special parts of a right and isosceles triangle. We're going to make this one look like a right triangle by putting the right angle here. So if we have the right angle there, we can sort of think of that like an arrow pointing to the longest side, that's called the hypotenuse, and then the 2 other sides that are adjacent to the right angle are called the legs. For an isosceles triangle, the two congruent sides are called the legs. The side that's not congruent is called the base, often because you see the isosceles triangle standing on its base like a bottom. The two interior angles are called the base angles. The base angles. And the base angles theorem that we're going to write down and practice in a moment tells us that the base angles of an isosceles triangle are congruent. Then we've got the angle that is across from the base. That is called the vertex angle. So I mentioned the base angles theorem as I was describing the special parts of an isosceles triangle. The base angles theorem tells us that for an isosceles triangle, when two sides are congruent, that the base angles also are congruent. So we say two sides of a triangle are congruent if and only if two angles are congruent. And those are the base angles that we're referring to. So the two sides are congruent. Those two sides are congruent if and only if the base angles are congruent. So if you have the triangle standing on its base, the legs are the ones coming down. Think of this like a little man standing here, little person standing here. Here are his legs. Those are congruent. And at the bottom, those two base angles are congruent. So as an example, to solve for x, well, in this picture, I see two sides that are congruent. So I'm going to take my picture and I'm going to rotate it, take my piece of paper and I'm going to rotate it so that I can see the two congruent sides being the ones that are coming down like the little man standing up. So if the little man is standing up here and these are his two legs, the legs are congruent, here's the base, these angles have to be congruent. These are the base angles right here, so those are congruent. So using the base angles theorem, I know that 2x has to equal 70, and then dividing by 2, I know x has to equal 35. That's a way to use the base angles theorem. There's a corollary to the base angles theorem. A corollary basically just means an extension. The corollary says that if I have an equilateral triangle, all three sides congruent, and I'm going to use a different congruent mark than I used up here, so these three sides are congruent, that means that the angles all must be congruent as well. So this angle, this angle, this angle are congruent. So what does it mean when I have three congruent sides? That's an equilateral triangle. So equilateral triangles are, now if all three angles are congruent, that's called equiangular. So equilateral triangles are equiangular triangles. I cannot have one without having the other. Equiangular triangles are equilateral triangles. So if I look at this example, solve for x and y, I see that all three angles of this triangle are 60 degrees. Therefore, I know that these three sides must be congruent. So how can I solve for x and y? Well, this side is congruent to this side, so I can say x plus 6 equals 8, and then subtracting for getting x by itself, I can see that x is 2. Similarly, I can make an equation to find out y by setting those equal. 4y equals 8, and dividing by 4, y also equals 2. Let's talk about two really important theorems for triangles, the triangle sum theorem being one of them. Take a look at this picture where I've got the three interior angles measured in this triangle, 30 degrees, 83 degrees, and 67 degrees. And To make it easier, I've shown you what they equal when I add them together. Now I'm going to grab one of the vertices of the triangle and I'm going to drag it so that I can make it any kind of triangle I want. So now it's an obtuse triangle and these angles have adjusted, but notice when I add them how much they equal. I'm going to change this one. I'm going to make it a right triangle. So look at those three angles, and up here still adds up to 180. In fact, I can move these three to make it as big or as small as I want to, and always these three angles will add up to 180 degrees. Can you think of why that might be true? Maybe this will help you to see it. I've got a triangle here, and I cut out 1, 2, 3 of its angles. I'm going to put them together vertex to vertex so that you can see what it looks like when I put them together, these three interior angles. So if I put these all adjacent to each other, do you see how together they make this straight line? How many degrees is a straight angle? This angle put together with this angle put together with this angle all together makes 180 degrees, makes a straight angle. So that's what the triangle sum theorem tells us, is that the three interior angles add up to 180 degrees. No matter what kind of triangle, the three interior angles add up to 180 degrees. So you may want to show yourself a visual. I'm going to number these three angles 1, 2, and 3, and we can write the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees, no matter what kind of triangle. So in this example where I need to find x, if I know all three angles add up to 180, I can say x plus 70 plus 30 equals 180, and then subtracting the 70 and the 30 from that side, so 70 and 30 together make 100. So 180 minus 100 leaves me with 80. That missing angle, 80 degrees. So now that we've talked about the triangle sum theorem, let's go back to this corollary of the base angles theorem. If all three angles are going to be congruent when all three sides are congruent, how many degrees do these angles have to be? Well, we know all three have to add up to 180. 180 divided by 3, because they all have to be the same, is 60 degrees. So let's mark in your notes that these three angles must be 60 degrees. Anytime you have equilateral or equiangular triangles, you know all three angles have to be 60 degrees. A corollary to the triangle sum theorem gives us a shortcut for when we're working with right triangles. So if I make this a right triangle, and I label these angles 1 and 2. So let's think about what the triangle sum theorem told us. All three angles have to add up to 180 degrees. So if this guy is already 90 degrees, what's left over for these other two acute angles? Well, 180 minus 90 leaves us with 90. So that means these two acute angles must add together to make 90 degrees. So we say for this corollary, the acute angles of a right triangle, how do we say adds up to 90 degrees? Are complementary. Complementary means they add up to 90 degrees. So in this picture, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Similarly here, I need to solve for x. Well, I already know this is 90 degrees, so what does that mean about these two together? They have to make 90 degrees. So x plus 42 equals 90, or just taking away 42, x has to equal 48 degrees. Finally, the exterior angle theorem. Again, let's take a look at this picture in action. So sometimes we need to find exterior angle measures. These angle measures outside of the triangle found by extending one of the sides of the triangle. Well, notice in this picture, we don't have this interior angle measure. We have the two interior angle measures that are farthest away from this exterior angle measure. And look what we've done with these two, 42 and 111 degrees. Add those together and it makes 153. 153 is that exterior angle. I'm going to grab this vertex and I'm going to drag it to make a different size measurement. 59 and 91. We're adding those two up and it makes 150. 150 is this exterior angle measure. I'm going to make that exterior angle acute. So you can see it doesn't matter what kind of triangle I have, these two interior angles add up to make this exterior angle. 16 and 58 add up together to make 74, and 74 is this exterior angle. Can you think of why? Let's go back to this picture to examine why that works. So I'm going to call this angle 70 degrees, and I'm going to say this angle is 50 degrees. Then this angle over here, I'm not going to label it yet. I'm going to extend the side adjacent to that angle so that I can get an exterior angle. This clearly is obtuse. I just don't know how much that measures yet. So if I know these two angles are 70 and 50, and I need to find this one right here, let's add up 70 plus 50. We get how much? Now, to find that missing angle measure, remember all three angles add up to 180 degrees. So 180 minus 120 gives me 60. So that means this angle is 60 degrees. How do I find the one next to it? Well, again, this is a straight line. Linear pair adds up to 180 degrees. So next I can say 180 minus that guy right there gives me 120. So this exterior angle out here is 120 degrees. So notice to get that, I had to subtract from 180 what I got when I added these two angles together, and that happened to be 120. Then I just kind of undid that by subtracting from 180 again. So you see how a shortcut to finding that exterior angle is just saying this interior angle plus this interior angle will make that exterior angle. So let's go back to our notes and write the exterior angle theorem. The exterior angle theorem tells us if I have two interior angles, the measure of those two interior angles that are far away from this exterior angle, let's call this interior angle angle 3 and this exterior angle 4, then the sum of those two interior angles will add up to the measure of that exterior angle. So these two interior angles that don't touch this guy, the two that are farthest away, add up to that exterior angle. So in this picture, how do I find that exterior angle? I take the two interior angle measures and I add them together, 20 plus 50. And I have my exterior angle has to be 70 degrees. So now take a few minutes to think about what you just saw and try to explain in your own words how the interior and exterior angle theorems are similar and how they are different. Thanks for watching.